Okay, so if I might have your attention. Evan, it's going to be okay. Did you have any questions from the assignment that I assigned to you on Friday that you turned in yesterday? Number 8. Okay, find the points determined by. Okay, so we make a fun little table here. But this time, since it's a parametric equation, I'm not just going to have an x and a y, I'm going to have a t also. And they told us to do -3, -2, -1, 0, 1, and 2. Okay? So the first thing I have to do is take the square root. What? Sorry. So the first thing that I need to do is take the square roots of all of these numbers. But I can't take square roots of the negatives, right? So this is going to just be 0, 1, square root of 2, and square root of 3. Okay, then the other one is 2t minus 5. So if I plug in -3, I get... If I plug in -3, I get... -11. I don't know why that just happened. If I plug in -2, I get -9, and then you should know already, since there's a 2 in front of the t, that means the slope is 2, so each one of these is going to go up by 2. So -7, -5, -3, -1, and 1. Okay? So that's the first part, is just make the table. Okay, then part B says to find a direct algebraic relationship between x and y. So that's pretty simple. I'm just going to take this and solve it for t. Okay, so if x equals the square root of t, then t equals x squared. And so I can substitute that into the y equation and get y equals 2x squared minus 5. Okay? Is y equals 2x squared minus 5 a function? Yes. Okay, then finally for C, I'm going to graph the relationship between those two things. And you can do that on Desmos if you want and sketch it, but it's pretty straightforward. What is it? It's a down 5. And then it's a parabola, right? And it opens upward, and the 2 tells us that it's a little bit steeper than a normal parabola, okay? And then you have to remember, we talked about this when we were talking about composite functions, that the domain of this function is determined by the domain of the individual pieces. And since I cannot plug a negative number into this right here, the parabola is going to start here and only go to the right. Okay? So this graph only has the positive half. Okay? And you can do that on our fancy little online calculator, and it should show the same thing. All right? Any questions about that? Do you want me to do it on the calculator? Yes? Okay. So square root of x and then 2t minus 5. So square root of x cos the square root of x, square root of t. Dang it. Square root of t
But it's like U7, U7, U or something.
It's like that.
Try that. U7, U7, U7. That's 6. Or I.
And there it is. Do you see it?
Yeah. I understand that.
Let's put this in parentheses. Yeah. Okay, and we went from -3 to 3. Okay, so there you see the half parabola starts at -5. Just only goes on the right hand side. If I made this value bigger, we'd see more of the parabola. I don't know how much of the graph they wanted us to show. Okay? K-E-W-L. Other questions? Is that it? That's all in the assignment track just for that?
I thought you talked about the word.
Okay, we can go with that next. All right, listen very carefully, please. Jordan and Madeline. The only reason that you would need to give me back that assignment is if you haven't turned it in yet. Okay? So those of you that were gone yesterday, I need that back from you. Otherwise, it's already in the grade. Already in the grade.
I know.
So, I had this thought. Actually.
Wow. That was me. And she didn't even hear it.
Okay, so is this the,
And she just doesn't go.
Clearing us out. Yes, I need my binders.
okay, Evan, you ready?
No, it's making fun of me.
Right, let's stop it. Just, no. Okay. This is the group worksheet I gave you? Okay. I will give them back to you, but we'll just go through it so you'll know. Okay, describe y as a sequence of transformations of f. Funny thing, we only started the first half of section 1.5, and so we didn't talk about this stuff yet. Okay, but we'll just take this as a little introduction because you've seen this before, a little bit of a review, and then we'll go through this more formally in the section notes and then have an assignment on it. All right. What does the 2 do to the graph?
Moves it up.
Nope.
Down.
This 2 right here. Stretch of 2.
And I know I'm doing. Maybe.
What does the -1 inside the parentheses do? Right 1. And what does the 2 at the end do? Up 2. Okay? Do you remember that?
Yes.
Evan?
Yes.
Okay.
Yeah, we did this yesterday.
Great. Just making sure I have your full attention and that you're not talking while I'm trying to teach. Just checking.
I got it.
Okay, good deal. All right, next one says, now we're going to do this with actual pictures, okay? So f of x minus 1 does what to this graph? Moves everything to the right 1. So this point is going to be here, this point will be here, this one will be here, there, 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 and there. So it's the whole thing moved 1 to the right.
I have a question.
Okay?
Okay, you know how there was different jobs yesterday?
Uh-huh.
What was the transformation person supposed to do?
I have no idea.
Neither did we, so I did my
Okay.
job then.
Okay, good job. All right, now let's try 2 times f of x minus 1 on this same grid. So we already have f of x minus 1. What is the 2 in front of the function going to do? It's going to be a stretch of 2. And the way we're going to do that visually is we're going to take all of the y values and they're going to be twice as far from the x-axis as they originally were. Okay? So this has a y value of -4. Technically, it would go all the way down here to -6, 7, 8. This has a y value of -2, so it would now be -4. This one is on the x-axis, so if I double 0, I still have 0. This is 1 above, so if I double that, it's 2 above. This is 2 above, if I double that, it's 4 above. 1 above becomes 2 above, and that stays on the axis. So now my new stretched graph looks like that.
Basically, you're making it bigger.
Yeah, this way. But since you were given an actual graph and an actual coordinate grid, you should not be guessing on this. So you shouldn't just go, oh, the 2 makes it bigger, so I'm just going to draw a taller thing. You were supposed to actually go, this was up 2, so now it's up 4. Okay, you're supposed to be a certain degree of accuracy. Okay, now things are getting messy. So it says sketch 2f of x minus 1 plus 2 on this new grid. So we already have the first part, right? Now we're just going to take this whole thing and move it up 2. So this point right here, instead of being -1, -8, will be -1, -6. So -1, -6 is about right there. This point right here, instead of being 0, -4, is now at 0, -2, because it's moved up 2. This point right here, instead of being at 1, 0, is now at 1, 2, because we're moving it up 2. And now I feel like we're going to lose some points here. This one is at 2, 2, so it's going to be 2, 4, because everything goes up 2. And then the next one was at 2, 4, so it's going to go up to 2, 6, or 3, 6, I mean. And then we work our way back down here and here. So now that's the same graph shifted up 2. Okay? So we did, what did we do first? Right 1, stretch of 2, and then up 2. Okay? Okay, and then that one they want you to do the same thing to get a sketch of y. Should we do that? Yes? Okay, so we're starting with this. Which one should we do first?
Don't you stretch it up?
It matters.
Yes.
The order matters because it's going to depend on if you go up 4 and then flip it over the x-axis or flip it over the x-axis and then go up 4. That's going to change it, right? So which one should we do first? Okay, let's learn that in the section, shall we? All right, so we had gotten partway through 1.5. Oh, okay. Right, so one thing that we didn't get to that we probably should have on Friday is we just talked about this briefly. I had to get Nate's attention so he would give us the answer that we were all waiting to hear. We talked about how do you find the inverse of a function algebraically. Because we did it parametrically, it was really easy. We just switched the things, right? The x and the y, but then we talked about how do you find that algebraically. So first of all, some notation that you should be familiar with, because this is sometimes confusing. If you see a function to the -1 power, that does not mean the function to the -1 power. It does not mean 1 over that function. That means the inverse of f, okay? So make sure you understand that, first of all. F to the -1, that's not an exponent, that's notation for the inverse, okay? And that's just flipping the x and the y. So if f of a equals b, that means f inverse of b equals a. You just switch those things around. So if we want to do that then algebraically, if I start with f of x equals x over x plus 1 and I want to find the inverse, how do I do it? Switch the x and the y. Remember, f of x is the same as a y, basically, right? So I can rewrite this as x equals y over y plus 1, and now I have to solve that for y. And that's a little bit tricky, because this is pre-calculus, even smarter than advanced algebra. What's my first step, do you think? Multiply both sides by y plus 1, and so I have to multiply the x times the y and the x times the 1. So that's going to give me xy plus x equals y. Okay? And then I believe I taught you this trick already. If I'm trying to solve this for y, and there's 2 or more terms with y in it, how do I do it, Jordan?
I'm confused how we got 2 x's now.
Because when I multiplied y plus 1 by x, the x multiplied the y and the 1. Okay? How do I solve this for y? Does anybody remember the little trick I showed you?
Divide by y?
Nate, we need you again. How do I solve this for y? How do I solve this for y? In terms of x. You can't say it already is because there's a y in the answer, and that's no good. What's that? No, because then I would get y divided by x over here, and then I would still have the same problem.
Switch, John?
No? Nobody? Okay, we got every term with a y in it on the left, and every term without a y in it on the right. So I'm going to rewrite this as xy minus y equals negative x. You see what I did there? Put this y over here as a negative, put this x over here as a negative. And then I can do the F word of mathematics. Factor out a y. So that would leave me x minus 1 equals negative x. Y times x minus 1 equals negative x. And now that I have that y factored out, Jordan and Nate's initial instinct is now correct. You wanted to divide by x. What do I divide by here? X minus 1. So if I divide over here by x minus 1, and then over here by x minus 1, these cancel, and I get y equals negative x over x minus 1. Okay? Just one little note for you guys that like to check your answers in the back. I could have also subtracted the xy from over here first and then done the same process. If I had done that, the x would have remained negative, right? I mean, would have remained positive. And then when I factored it out, I would have gotten a 1 minus x instead of an x minus 1. So if you see an answer in the back of the book that looks exactly like yours, but all the signs are switched, that's the same. Okay, you just did it in a different order. So if you get x over 1 minus x or negative x plus 1, that's the same thing. All right, so this is the inverse of our original function. That's how you do that. Okay. Did you read that fun little paragraph? Let us candidly admit they're basically saying we're just not really going to do that very much.
What does candidly mean?
Candid means I'm being honest, I'm being open. Not like usually lying, but sometimes you just don't say things. So I'm like, let me be candid.
Let's have a candid.
Yeah, right. Okay, and then we talked, I believe, about the graphs of inverses being a reflection over the line y equals x. Do you remember that? Okay. All right, so let's do this graphically then. let's say you start with this function here and they want you to graph the inverse. So we don't really know what this equation is, even though we do know that it's x cubed plus 1. The way that you would find the inverse of this is you could identify as many clean points as you can. So what's a point on here that you are pretty confident you could find the coordinates of?
0, 1.
0, 1 is a good one. I also heard 1, 2. What else? 2, 4. I think 2 is actually maybe somewhere up here, because this is a cubic. Negative 1, 0. So 2 is going to be way up there, so let's not mess with that. So the way that you can find the inverse then is the inverse is switching the x and the y, right? So this point right here, instead of being negative 1, 0, will become 0, negative 1. So that's this guy here. This one right here, instead of being 0, 1, will become 1, 0. And then this guy here, instead of being 1, 2, will be 2, 1. And so if we wanted to try and get one more sort of, this is like 2, 8. Do you recognize this from the 10 basic functions as being a x cubed? So you probably know that the 2 is going to be some sort of a, I don't know what. So then that's going to be over here somewhere. So that gives you the rest of the shape. And so it's going to look something like that. Okay? And hopefully you can sort of visualize that that's a reflection of the original graph over the line y equals x. Okay? So to find it graphically, find as many points as you can on the original graph, just switch the x and the y just like we did algebraically, and then graph that new set of points. Yeah?
Yes.
Okay. Fun and games with inverses. Okay, then I think final wrap up with the inverses, and then we'll talk briefly about transformations, is if you take the inverse and the function's 1 to 1, so that, remember, if a function is 1 to 1, that means its inverse is also function, then that means f of g of x will equal x, and g of f of x will also equal x, because they're inverses. So everything you do when you plug it into the first function, you undo it when you plug it into the second one, so you end up right where you started again. Okay? Okay, guess not. We're not quite done with this idea. So show algebraically that these are inverses. What I'm going to do is I'm going to figure out what f of g of x is, and then I'm going to figure out what g of f of x is. And what would I like those both to be? For those to be inverses of each other, what has to happen in the end? Okay, let's find out. So f of g of x, what do? I plug in, well, I already did plug in x to the g function. I got cube root of x minus 1. Now what? Put it into the f function, okay? So I'm going to go cube root of
X minus 1.
X minus 1 gives cubed plus 1. What happens to the cube root and the cube?
They cancel.
They cancel. So that means that this really becomes x minus 1 plus 1. And x minus 1 plus 1 is obviously x. Okay, so we showed that f of g of x equals x. Now we need to show that g of f of x also is going to be equal to x. So I'm going to take this piece right here and substitute it in for that x. So cube root of x cubed plus 1 minus 1. This time, what do I do underneath the cube root first? Cancel the 1's. So then I have the cube root of x cubed. And since the cube root of x cubed is just x, we have shown algebraically that those two functions are inverses, okay? So this would be a question where the work would be the answer, not the answer itself, because you already know what the answer is going to be. The answer is going to be x. So you'd have to show me the work that you did to get to that point. Okay? Any questions about that? Okay, transformations finally? No. Did I give you a worksheet from the wrong section? don't know. Okay, so that's the summary. And we don't want to do that. Okay, no transformations. I don't even know what that was all about.